And now I'd like to introduce our next speaker, Mr. David Chi, the Strategy and BD Manager of RadiciGroup.
现在欢迎来自南地奇集团战略市场开发经理齐元先生。
So, okay, good afternoon, everyone. Thanks to IDI and also Eastant. I'm very honored to be here, invited to present you who we are, what we do, and how we can do better with our customers together. And also, I'm very pleased that I'm the only Chinese speakers today for the first one, especially thanks to the good relationship between China and Italy. So, okay, first of all, please allow me to introduce about RadiciGroup. As you can see here, RadiciGroup has many 3 BUs, special chemicals. We also produce the yarns and textiles, and also we have the high performance polymers BUs. So in 2020, our sales turnover is over 1 billion euro. And here's our history. So we are established in 1921, an Italian company, and from 1960 and 1980, we started our own implementation of PSX and PSX6. And from 2013, we launched the whole series of the aromatic nylons, which including the high temperature nylons and also the PPA. Okay. And I would like to give you a very small hint about how the polymerization is processed. So as you can see that we put the catalyst and also the raw material into the reaction tank to polymerize the PSX and PSX, and then we use the extruders to produce the pellets for the next compounding procedures. So here is our global capacities about the upstream products. So basically, let's say, for the polymerization of PSX6, we are global top 6 manufacturers. So we can maintain the very stable supplies of our materials to the global customers. Okay, and here's how we can compound the materials to supply our customers in China. As you can see here, we put the raw materials into the twin screw compounding lines filled with the fillers like the glass fiber or other additives. And to granulate, we extrude it, we call it the spaghetti, and then cut the spaghetti into the pellets for our customers to use. So you can see here. So in a summary, as upstream integrated nylon suppliers, we are the top 5, and we have over 100 years of history. So as a raw material suppliers, we also think and invest a lot to increase our material performance for our customers' products to meet their needs. So as you can see here, these 4 topics are the hottest topics in the automotive industries. So for example, the weight reduction. We know that there's a lot of plastics part in the interiors and exteriors. And actually, I would like to show you that we also help our customers to make a lot of plastics part to replace metal in the chassis and powertrain systems. So here is the very good technology. We call it the topology optimization. As you can see here, we got the 3D CAD of the metal part from our customers. So we can help the customers to run the topology structure optimization. So we can find out which are the core parts or areas which is needed to survive the CTQs of the working conditions. And then we can revise, or we can optimize the structures from the metal designs to the plastic designs to reduce the weight by a very perspective proportions, as you can see here. And besides, as we all know that plastics materials is ultimate stress at break is much lower than the metal. So that is worries coming from our customers. How can I use the plastics to replace metal since the stress of the materials is much lower than the metal? Actually, this could be designed by different structures with a lot of ribs. So you can see here, even for the metal, even for the plastics part, we can also achieve the same load structures above to 70,000 newtons. That means 7 tons impact for the plastics part. And this part can be a very good weight reduction target for our customers. Meanwhile, we now in China, we can also help the customers to run the CAE analysis with the whole assembly available and also the hypoplastics materials with the 3D analysis. Okay. And this is another innovation product we launched recently. We call it composite laminate. See, here is the example. We help our customers to run the CAE analysis for the hydrogen tank. So basically, this tank is produced by metal. The weight could be around 30 kgs. But we use the composite materials. The weight is only 6 kgs or even lower. And we can use the CAE analysis software to help the customers to design the different layout of the laminars around this tank to achieve the cold temperature best pressure test, which is up to 75 micropascals, which is bearing higher pressures compared with metal. And the weight reduction could be very, very good for our customers. So then we think about the downsized engines. So the engine areas is the main areas where the polyamide are widely used. So, but nowadays I will show you a very small video. You can see here is the engines, and you can see here that the downsized engines requires to use less fuel and generate more power. So that gives us the material suppliers a big challenge, because the working temperatures is going up very sharply from 150 degrees Celsius to now 230 degrees Celsius. And working pressures is also 4 times higher than the past. So the materials need to bear higher temperatures to maintain a very good strength after a long time heat agents. Okay, so here I can show you that 3 years ago, we successfully launched the high temperature nylons. We call it Nextream. This is our high temperatures, super high temperature nylons. We can see that these materials can keep very good strength after a long time heat agents at very high temperatures, working temperatures. And then the third topic is like electrification. As we all know that due to the new energy vehicles development boom, and also the 40H technology, there are a lot of requests for the electrification of the component in the vehicles. Here is the a summary about the new energy vehicles system. Mainly 4 parts: e-motor, battery, and in control. And this is the new, we call it the second era of the new energy vehicles development in China and globally. I would like to show you that a video about Tesla. As you can see, Tesla's new designs of the powertrain is quite compact and very simple. There's only 3 parts. Here is the hot pump system, battery system, and e-motor systems. They put all the e-control systems compacted or integrated into the battery so far. Okay. So now for the hot pump technology is innovation technology for the new energy vehicles, because in the past we all know that for the end users of new energy vehicles, they were not turn on the air conditioning at the cold temperatures, because this technology is mainly focusing on the PTC, preheaters, which can consume at least 30 to 40% of your battery capacities. That is the reason why most of the end users would not like to turn on the air conditioning at the winter seasons. But with the hot pump, you don't need to consume any energies from your batteries. And this is the new technology. And here's the part we produced for our customers. So for very simple to, this technology is complex, but I want to make it simple to you. Here you can see there are 4 loops. The first loop is the battery loop. Battery loop means that this is the battery thermal management system, including heating and cooling, and the e-motor heating and cooling, and front radiators heating and cooling, and air conditioning heating and cooling. So basically, in the past, these 4 loops are totally separated, not connected together. But now with the hot pump technology, we can use a control valve here to connect all these 5 loops together, which means that When you drive the vehicles and when the battery is heated up and it's not needed for cooling down, then you can use the coolant from the battery to transfer the heat to your air conditioning systems to generate the heat for your air conditioning warm up. So that is not going to use anymore the electricity powers from the battery. So that is the key point to why I would say 80% of the OEMs now is going to transfer from the old technology, PDC technology, to the hot pump technology. And here I'm very honored and pleased to announce to you that as raw material suppliers, Radici is the global first one. By now, I think by now is the only one successfully work with our customers to launch the first vehicle inductive wireless charging component in China, but also in, globally. So here is the architecture or the exposed schemes of the component. We call it the ground assembly. So this part is generated the mechanism field through the electricity power, and then there will be another part which we call vehicle assembling. This part receive the magnetic field to generate the electricity to recharge your battery or give the power to vehicles. So we help the customers to define the electricity properties, try not to block the magnetic field strength. But meanwhile, we also help the customers to run the dynamic thermal analysis to try to optimize the structures to minimize the heat dissipate, just like the former speakers are talking about the LED. This is the same theory. And this is the first global first one, the FAW Hongqi EHS 9 vehicles, and this is the part with our materials. And very important thing is that these customers requires the very restricted strength of the component, so we have to make a lot of design with ribs, because you can see here is the CAE simulation we run for the customers. With the tire rolling, speed is 10 kilometers per hour, but the weight is 1.35 tons, which means the vehicle weight is 4 times higher than this by this 1.35 tons. And the customers requires that when the tire roll up onto the surface of the component of these plastics ones, the vertical deformations need to be within 1 millimeters. That is very hard. So we help customers to redesign the ribs and to achieve that, and now it's commercialized. And I introduced who we are, what we do, and I want to introduce you about how we can do it better with our customers. So here is, first of all, as a raw material supplier, so we have to expand our data available for our materials that our customers can use. And you know that, as you know, that global famous CAE software or material center is called the DGMAT. And here's our materials validated numbers among our, let's say, competitors or partners. We're very top 10, etc. And besides that, we can use our software to help our customers to quickly design or optimize the design of the part. As you can see here is the examples. We can use our function of the software to achieve near real-time simulations, which means that if you can see here, for some part, we can make the redesign of the structures, and the result will be simultaneously coming out. You don't need to wait for like 1 hour or 2 hours or 2 days. It just come out when you redesign the structure. So like here, I cut off a hole, and then the stress result or deformation result will coming out simultaneously when you down the change of your structures. So we have these capabilities, have our designers to redesign and quickly design the part at the real time. And besides, we can also help our customers to run the multi-flow analysis, not only to solve the injection process optimization, but we can also help our customers to adopt the pre-shrinkage pre-shrinkage or pre-deformations technology to solve the problems like these gap close problems. We can solve that. Meanwhile, we can also link the manufacturer process with your part functional, because we know that during the manufacturer process, there are a lot of unavoidable defeat. But when you do the CAE analysis, you cannot take that into account for the part design. But now we can have these models to link the the part design and also the manufacturer's process. We can take the unavoidable defeat caused by the manufacturer process into account to the part design to achieve the real real close to the reality's result. So you don't need to worry about any defeat from the manufacturer process anymore. Okay. So besides, last but not least, 2 years ago, we also launched our capacities for design for the high-speed impact. So now, for most of our materials, we also expand our high-speed data for our customers to use. Because as you know that the materials behave totally differently at low-speed impact and at high-speed impact. So we now also expand our data for the high-speed strength and also help our customers to run the crash simulations as well. So Radici as a global nylon integrated solution supplier, so we don't only supply the materials to our customers. As you can see, we have totally profound functional teams to support our customers with, for example, our sales team to support the pre-sales and post-sales service. And also we have the BD team and the marketing team to supply our customers with some system or market benchmark reports. And besides, we have the CAE team to help our customers to co-design and validate parts with our materials. And also, we have the local product R&D centers. We can develop the materials based on the customer's request locally, and the feedback would be very, very quick. So, okay, that is my presentation. Thank you so much.
David, a very extensive presentation on your work here in China. I'd like to open up the floor to any questions for David and his presentation. Okay, going once, going twice. Oh, I think we have a few questions here.
I say Chinese. 李总你好，我想请教一下，按照刚才那个汽车这种比如说电驱，然后电动，那么未来的汽车是不是就是标准的一个底盘，再加多种的然后空间，它更多的这个以后汽车也自动驾驶，也不用再去开，会是这样的一个趋势。谢谢您。
Sure. Or an answer in China. I repeat his question. Question is like, he has seen that my presentation mentioned that the whole integrations of the component for the battery, e-control, and e-motor. So his question is like, in the future, maybe there's only one need for the chassis of the vehicle for the new energy vehicles. So you don't need any other parts because every component could be integrated into the chassis. So my answer is that why not? It's possible. But if you see now, it's already come to reality because most of the new energy vehicles OEMs, they are developing the chassis with the capability to integrate different size of the battery. And if you think about e-control, more and more e-control components now integrated inside of the battery. For example, the BDU, PCU, and ECU are all integrated into the battery. So I would say that battery and e-control will become to one component. And for the motors, for sure, Motors right now, they have to integrate the inverter into the motor. But I would say 5 years ago is unlikely because in China we're not leading the, let's say, the IGBT technology, which is widely used, or let's say the core CPU for the inverter. But now in China, I think the technology is come to reality. For example, BYD is the first one in China to produce the IGBT by themselves. So he would like to also to transfer this technology to other OEMs. So now we are capable to integrate the inverters together with the e-motor. Then they will become to one part. And for hot pump is also the very important system to integrate all the loops where the coolant is going around in circle. And this hot pump can integrate all this coolant together to transfer the heat to one place where this place needs a heat, or transfer to another place where the place need to cool down. So all these things could be integrated to chassis for sure.
Thank you, David. Okay, if there's no more questions, oh, we have one more over here.
就是您刚讲的一个，我先说中文，再说英文，然后一会儿再翻。就是您刚讲关于汽车空调那一块，我没太听懂。就是说，很多之前的汽车处理方案的时候，那空调是说，因为那个方案导致冬天不要开空调。因为我听说过，好像就是说冬天不要开 AC， 开了之后可能对车有损伤。好像是之后您的方案就会导致可以让冬天开，其实也无所谓。Just briefly English, I mean, if we turn on our AC in the car, it might hurt the car because of the AC system in prior years. And currently, because of your Radici technical solution, can solve this problem. Could you briefly explain that?
Yes. Actually, if you see the first generation of Tesla Model 3, the air conditioning system, they adopted the technology called the PTC, positive temperature system, with a preheater. That is quite a simple component. They put a lot of wires into these systems and use the electricity power to go through these wires to generate the heat, and then use the fan to blow up the airs from outside to inside. And the wind goes through these preheated wires. The air can be heated up to generate the heatings with your air conditioning systems. But if you think about the wine be heated up, it must need electricity power. And this is electricity power is coming from the battery, and will consume at least 30 or 40% of your battery pack's capacity. That is the reason why many end users of the new energy vehicles would not like to turn on the air conditioning with this technology. But for the hot pump, it's totally different, because this heat is not generated from the heated wine. Is generated, for example, when you drive, when you start turn on your vehicle, the battery is working, but at this moment, maybe 1 hour later, within 1 hour, the battery does not need to cool down. So this heat, you can use it from the battery inside by using the coolant to transfer this heat from the inside of the battery to air conditioning to supply you heat. But when you drive, let's say 3 hours later, then this battery needs to be cooled down. Then there will be another loop, for example, the front radiators, to transfer the coolant, the coolant inside of the battery to cool down your, let's say, battery. And this moment, because the e-motor is very hot, it's rotated very fast, it's very hot, and you can use the valve to connect the air conditioning heating systems loop and the e-motor loop. Then the heat from the e-motor can come from the e-motor inside to your heating systems of air conditioning. That is the series of the hot pump technology. It does not need any electricity powers. It's just a control to control this pump with different channels. Normally, you will have at least, for example, the Tesla Model Y, they have 10 channels. And for General Motors BEV3, they have 6 channels to connect all these loops.
One more time. Thank you, David.